Hey guys, hope everybody's doing okay. What we're going to do right now is take a look at how we name ionic, covalent, and acidic substances. This is the last part of our nomenclature unit, and we want to look at each of the three categories of substances we've dealt with so far. Again, ionic, covalent, and acidic. And how do we name each of those three types? So they all have their own set of naming rules and little kind of nuances that go along with them. So we'll do a couple examples, and we'll see how it goes. This will be a quick video tutorial on how to do all that. So we'll just go through the flow chart here. We'll do a couple practice problems, and then you'll be able to do some more on your own. So we'll get started with what we have here. Okay, for the first one, we have Mg3PO42. So that's number one, is where we're going to start. Okay, so the first element is always what we want to look at first, and that is Mg. So you look at your flow chart, and it says, is it ionic, covalent, or molecular? Well, covalent and molecular is really the same thing, or acidic is what I meant to say. So ionic starts with the metal, and that's what magnesium is. So we know we are already here on that part of the flow chart. Next thing you look at is the first ion in groups 1, 2, 3 zinc or silver? So the answer to that question is yes. Magnesium is in group 2 on the periodic table, right? So we go here, and it says simply write the names of the first and second ions. So let's do that. So the first ion is Mg. The name of that is simply magnesium. And the second ion is PO4. So you ask yourself, what is that? Well, PO4 is the ion phosphate. Okay, and that takes care of it. So you're done number one already. So that's very simple. So there's nothing else to go to do here. So name the first ion, magnesium, second ion, phosphate. Students always get messed up because they try to use these they try to do something with these subscripts, right? The 3 and the 2, and they get all messed up with their name. The flow chart here doesn't say anything about that, right? The flow chart just says write the names of the first and second ions right here, okay? So we definitely want to just follow what the flow chart says and take it from there, all right? So let's try the next one, okay? Next one is obviously number 2. AlCl3. Okay, so again, is it ionic, covalent, or molecular, or acidic? So it starts with aluminum. Okay, so aluminum is a metal, so we're here. Is aluminum in group 1, 2, 3, or 13? We talked about that in class 3 and 13, depending on your periodic table, is the same group. Zinc or silver? Well, the answer to that question is yes, because aluminum is in group 13 or 3. So again, we're down here. Simply write the names of the first and second ions. Okay, great. So Al is what? Well, it's aluminum. Okay, a little sloppy there. And then what is Cl? What's the name of the Cl ion? Now I know Cl is chlorine, but we're talking about the Cl ion here. And the Cl ion is Cl-1, and that is called chloride. Okay, so the answer to that one is aluminum chloride. Simple as that. Okay. Next one, number 3, FeSO4. So this one is a little bit more complicated, not by much though. Okay, so start off how we always do. It starts with Fe. All right, and Fe is what? Well, it is a metal. All right, so we're going to start here. Okay, then ask yourself, is it in groups 1, 2, 3, /13, zinc or silver? Well, iron is not in group 1, 2, or 13. It's not zinc, it's not silver. So what do we do here? We have to go to this part of our flow chart. It says use the Roman numerals to show the charge of the first ion only. You could also use your Latin endings here, like your Latin roots, your classical naming system, the ic or us endings. But to keep your life as easy as possible, you could just worry about Roman numerals. So why do we have to use them for this example? If you think about it, number 1 and 2, magnesium, I'll do it over here. Magnesium is always a +2. It always was, it always will be, right? Same thing with aluminum. Aluminum always was and always will be a +3 charge, what we memorize it as. But for iron, we didn't memorize a specific charge for that one, because if you look on your ion cheat sheet that you guys have, iron could be a +2 or a +3. So if you just put iron and then your second ion is sulfate, there's not enough information there, okay? So if you just have iron sulfate, we need more, okay? Because if I'm reading that and I'm like, okay, iron sulfate, let me think about this. I know sulfate's a -2 charge, but what's iron? Like, like iron could be a 2 or a 3, so the formula is going to look different depending on what version I have. So you got to do a little bit of work to figure this out. It's not that difficult though, so I'll do it over here. You have FeSO4. What you have to do is figure out the positive charge on iron through the negative ion. Like, use your negative ion because you know that, right? So just a little simplification here. What's the charge on sulfate? Well, it's a -2, right? Sulfate's always -2. And there's only one of them here, okay? So one iron has to balance out one sulfate, all right? So if one sulfate gives you a -2 charge, the one iron that you have has to be a +2 charge, okay? Here's important, right? The Roman numeral tells you the charge, not how many you have, all right? So this will be iron 2 sulfate for your answer. The 2 has to be there, okay, or else you don't get credit for that. You also could use the Latin, like, classical naming system, so that could be ferrous sulfate. You'd still get full credit. Okay, so that takes care of number 3, and using this part of the flow chart. Let's do one more that way, which is actually number 4, Sb2O5. So Sb is a metal. We're here. It's not in group 1, 2, 13, /3, silver or zinc. So we're here. Again, use the Roman numerals. So we have Sb2O5. Let's figure it out. Sb is what element? Well, Sb is antimony. And then O is oxide. Sorry, it's so sloppy. So it's antimony something oxide. Now, antimony can have a bunch of different charges, so we can't just say antimony oxide, because I won't know. I need to figure out what the charge is on antimony using, and I'll use my Roman numerals to determine that. So there's my parentheses for the Roman numerals. Again, sorry, it's so sloppy. Okay, let's figure it out. So we don't know the charge on antimony right here, but I do know the charge on oxide. Oxide is always, because it's in group 16 on the periodic table, that's our -2 group. Okay, so oxide's -2. Well, there's 5 of them, right? So what's the overall negative charge going to be from the oxides? You have 5 -2 ions. That gives us -10. Okay, so you know that antimony has to balance that out and be a +10, okay? The thing here is you need to figure out how many, or I'm sorry, what the charge is on antimony to give you that +10 charge. Well, the charge on each antimony can't be +10, right? The charge on each antimony has to be what? +5, okay? So it's antimony 5 oxide, all right? A +5 ion, 2 of them gives you a +10 overall charge, okay? So if we, I want to erase part of that. I don't know how to. So if you like drew all this out like you did when I taught you this, you would see that you have O -2, 5 times. Okay, so it gives you -2, 4, 6, 8, 10, -10. And you have 2 SBs, because that's the formula, right? So you have SB, SB. All right, so you have -10. You want to get +10, so you have to do +5, +5. All right, so antimony 5, because of the charge here, oxide. Okay, moving on. Let's find another one on here that I want to do that goes into this middle column here. So let me scroll down a little bit if I can. Okay. Number 9. Number 9 is SF4. So it starts with S. S is a non-metal, okay? So all you have to do here is follow the covalent rules. These are really easy. You're going to love doing these. It says use prefixes to indicate how many of each element you have. It gives you an example. So S is what element? S is sulfur. There's only one of them, okay? So it does say to use the prefixes to indicate how many, but you don't use the prefix mono on the first word. We've done something like this before. So if you have CO2, that's carbon dioxide. All right. If you have CO, that's carbon monoxide. All right. So the first word, doesn't have it will have a prefix if it needs it, but you won't have the mono there. It's not mono carbon monoxide. It's just carbon monoxide. If you had something like this, if you had N2O, that would be dinitrogen monoxide. Okay. My pen's losing its juice here. So dinitrogen monoxide would be N2O. All right. So you only use mono on the second word if you need it. You never use it on the first one. So how do you wrap this up? S is sulfur. F is fluoride, but there's 4 of them. So use your prefix for the number 4, which is tetra. So that's tetra. This is a mess here. Try to fix it here for you. SF4, sulfur, tetra, fluoride. Losing battery. Sulfur tetrafluoride. Okay, so that takes care of number 9. Things like number 9, these covalents are always going to end in IDE. All right. And again, you don't use mono for the first word. Any other prefix you would use. For the second word, use any prefix. Okay, it can be mono all the way through deca. So the second word always has a prefix. So does the first word, other than mono. Ending is always IDE. All right, so there's not too many of those on this worksheet for practice. They're not usually as common. They're so easy. But that's how you do those. Okay, let's take care of the last couple here. I want to do number 17. So we'll do that next. It's HCl. So it starts with H. Acids start with H. All right, so we're going to look at that. And you want to look at what comes after the hydrogen. So you have HCl. Okay. And if you want to ask yourself, after the hydrogen, I have one element. Okay, it's just Cl. So my category would be H plus one other element right here. Okay, so it's a binary acid. If you remember when we wrote formulas for this, if you start that acid with the prefix hydro, it means H and one other thing. Okay, so in this case we have H and one other thing. So it starts with the prefix hydro. Now this is anticlimactic, so it's the example on the flow chart, okay? But it starts with hydro. Cl is chlorine, so you change the ending to an ic. Okay, so it's hydrochloric. And you have to put the word acid at the end. Yeah, it's mandatory. You can't be lazy and skip that. It's not hydrochloric. It's not the name. It's hydrochloric acid. All right? So that is number 17. If you have something like HBr, okay? If you have HBr, it's hydrogen and one other element, okay? So the name for this one would be hydro what? Hydro, that's bromine, make it ic, hydrobromic acid, okay? If you look at number 30, if you scroll down to number 30 on here, I don't want to because I'll lose the flow chart. Number 30, I believe is, let's see, let me double check, H2SO3. Okay, so let's do that one. All right, H2SO3. Okay, now for this one, you look at what you have. Starts with hydrogen. Okay, so it's acidic, but there's a polyatomic ion after the after the hydrogen. Okay, so it's not going to be like this. All right, so it will not start with hydro. Okay, it's not going to. It's only one element after the hydrogen is when you start it with hydro. So in this case, it's just H in your polyatomic. It's very easy. Name this polyatomic ion, which is SO3. So based on our naming rules, you know SO4 is sulfate, SO3 is sulfite, right? Okay. So you take your ending, your ITE ending in sulfite, and just change it to an OUS ending. Okay. This one's a little weird. That's why I picked it, because it's not sulfus, right? You got to fancy it up a little bit. It's sulfurous. Okay. So that would be sulfurous acid. That's it. It's not hydrosulfurous. Okay, let me see if my pen could get this to write here. All right, good enough. So it's sulfurous acid. All right, not hydrosulfurous acid, just sulfurous acid. So if you look at the, and that's it. So if you look at the flow chart here, you have HCl. That's hydrochloric acid. Okay. If you have HClO3, okay, then that's going to be chloric acid. Look at the difference there. It's hydrochloric and then chloric. So because you have the ClO3 here, let's see if this works. If you have the ClO3 here, okay, not really, then you're going to end up with your H in your polyatomic. So you don't have that hydro prefix in the beginning. If you just have HCl with that one element, then you have hydro whatever-ic acid. So HCl is hydrochloric, HBr hydrobromic, HF hydrofluoric. H in a polyatomic, you drop the hydro, just name your ion, and change the ate to an ic and the ite to an us, and you should be in good shape. Okay? I mean, I could do a million more practice problems for you, but honestly, the best way to do this is to just practice yourself. So you need to practice, you need to grind it out, you need to do a bunch of them, and then you need to check your answers and see how you did. See where your mistakes are being made and take it from there. So none of these are difficult, individually, but when you look at all of them as a whole, it could definitely be a little bit confusing trying to keep everything organized. So this is a quick tutorial for how to do at least one of each in every category. Work through the practice, and if you need any more help, just let me know. All right, thanks guys.